All right. So, hello everyone, and welcome to this new webinar session. This is Alan Murgis, the founder of CrowdField, and it's good morning here in Australia. Good evening for you guys over there in the US. So today we're going to be talking these very two hot topics: Python and LLMs, large language models, in oil and gas applications. I'm particularly very excited about this one. I've been also like Yoshi, an AI activist on LinkedIn, if you follow me and see my feed. And I think it's fair to say that LLMs have changed or are continuing to change the coding game. And this is regardless of your level of expertise with Python or with any other programming language for that matter. So today I'm very happy to have Yogashri Pradhan as my guest. She's the founder and CEO of Iron Lady Energy Advisors. She has 10 plus years of experience in unconventional asset development and production engineering. She's a former lead production engineer at Chevron with experience in the Midland and Delaware basins. She's been recognized as distinguished alumni from the University of Texas, Hard Energy 40 Under 40, and a multiple SPE award recipient. She holds degrees from University of Texas, Texas A&M, and Chicago Booth School of Business. And Yoshi is a licensed professional engineer in Texas and New Mexico. So just before handing over to her, just a bit of housekeeping. We have about 40 to 45 minutes for the talk. We're going to have 10 to 15 minutes Q&A at the end. Please stay muted throughout the session. And if you have questions, just raise your hand with a little hand icon at the bottom of the screen and wait for my cue before unmuting yourselves, or simply type the question in the chat box. Now, with Joshi's consent, this session is being recorded and it will be published on our YouTube channel for later distribution. So, with all of that intro out of the way, I'm just going to allow screen sharing and take it away, Joshi. The stage is yours.
Awesome. Thank you so much for the kind introduction and the kind words, Alan. I'm going to go ahead and share my screen. There goes the inception of screen sharing. And I will put this in presentation mode. Alan, just give me a verbal cue to let me know that you can see my screen.
We can see and hear you loud and clear. It's all good.
Perfect. All right, folks. As Alan mentioned, today I'm going to talk about Python and large language models in oil and gas applications. You might be thinking about the advent of coding and whether if coding is still going to be a necessary skill set, knowing that ChatGPT Copilot can generate lines of code based on your prompt engineering. And I will go ahead and even define what prompt engineering is later in the presentation. But I want you guys to think about this in the back of your mind in terms of why we're talking about this today, and then how we can make large language models work for you and still upskill in the Python coding, because you're going to need that experienced eye and you're going to need that experience to litmus test and to understand what is happening in the large language models. And the good news is this is all in context of oil and gas applications. So what are some of the oil and gas problems we can solve today and make LLMs work for us as we code in Python, or as we generate the Python code in Copilot and ChatGPT and Claude and anything that you fancy. So let's talk about why this matters. As I mentioned to you, you may be reaching an existential crisis whether if you want to learn Python coding, because ChatGPT, Copilot, all the LLMs that are out there can generate such code. So instead of developing code from scratch, you can do instead of generating code from scratch, you can use AI assisted workflows in that regard. Now, engineers are still important, and understanding Python is still important. In fact, LLMs elevate your job because the LLMs are developing the code from its foundational models, from what you have prompted. And as the engineer, you are the evaluator. You're the holder to make the decision on whether to execute the code, to change the code, to do anything you want with the code for your oil and gas application. So therefore, I'm going to talk about the strategy of Python and LLMs. You have the speed because the code is generated for you. You have the scale because you can generate it really fast. And then you can democratize the skill by examining the code and truly evaluating whether the code is going to work for you. So for speed, what used to take days for coding, like the data cleaning, decline fitting, dashboard generation, can now be done in minutes. The scale, LLMs allow engineers to manage hundreds of wells and automate repetitive tasks and build scalable forecasting systems. And for skill democratization, so for example, you got junior engineers, you got field techs, and even people with no coding background can contribute meaningfully to Python workflows. Now, for non-coders and for field techs and for junior engineers, again, this is where you're the evaluator and you're providing the inputs through the prompt engineering. So this levels the playing field and unlocks new talent pipelines. So this allows a lot of people to be able to interact with a Python code rather than upskilling and rather than starting from scratch to upskill. You are still upskilling, but it's a lot faster. So the current role in Python and oil and gas, let's answer that question. And this is not an exhaustive list. You have data wrangling in SCADA, Aries, and Spotfire. You're parsing Aries flat files and merging with SCADA time series. You're automating Spotfire export, cleanup, and reformatting. SQL queries and database integration, like with Aries, Snowflake, Whitson Plus. And then you have API calls to public data sets, like the Railroad Commission, FRAC Focus, the Texas Railroad Commission, I need to clarify, and then EIA. You got decline curve analysis, node modeling, and type well generation. You can do bulk well type well generation across pads and benches, auto-fitting decline curves with uncertainty bands. So with your P10, P50, P90, you got EUR prediction using hourly flowback data, and then unit plots and residual analysis fit for validation. And then you have and the way where Python has natively been used, along with older coding languages, has been in simulation prep and post-processing. So I don't need to explain too much here, but I will say that the current role of Python using in oil and gas is you can definitely develop your own reservoir simulator from the code. Okay, I also need to define some terms because for those that will be looking at the recording later on, some of you may not have a background in large language models, in artificial intelligence, or in the terminology. So I need to define what this is. You got large language models, that's what LLMs stand for. And I noted some of those really famous or enterprise level models like Copilot, ChatGPT, Grok, which is the foundational models from Twitter, or X they call it now. You got Claude, you have Perplexity AI, you have Notion AI. You have a long list of AI, a long list of large language models that can be used that are at your fingertips as long as you subscribe to them. So AI models are trained on vast amounts of text and code to understand and generate human-like language. That's the generative AI portion of it. That's the prompt engineering. That's where it's important for us to be talented at. And then that's where the code is to develop that to develop that, like to know the sniff test, the litmus test of what is wrong with the code, why the code won't automatically execute if you just copy paste it. You need to be able to modify the code accordingly. And that's where the upskilling in Python ends up becoming important. So you have examples like Copilot, ChatGPT, and other transformer-based models. And then it's capable of interpreting natural language prompts and producing structured outputs like code, summaries, and explanations. So the good thing about with the Python code and through large language models is that you can develop comments in that's great for documentation purposes for Python. Now I'll talk about like the capabilities of engineering workflows. So code generation, you can write Python scripts from plain language prompts. Obviously, I wouldn't suggest this because this is too general, but I would say, but you can answer an example would be build a type well forecast from the CSV. And then you can generate boilerplate functions for data cleaning, plotting, and simulation prep. You have debugging support. You can identify syntax errors, suggest fixes, and explain logic flaws. Provide context and aware troubleshooting for complex workflows. Then I'll talk about documentation and explanation, like generate doc strings, comments, and usage examples. Translate code into readable summaries for cross-functional teams. And then you have workflow automation. You can build repeatable scripts for SCADA parsing, Aries integration, or decline fitting, trigger multi-step processes with minimal or manual input. So these are not an exhaustive list for the workflow, but this is just helping you figure out how Python has been a tool in our toolbox and how it cannot be abandoned. Generating code, debugging support, documentation explanation, and workflow automation. And the LLMs are like they've been well trained from a lot of the Google, just a lot of the public information that is out there with Python, especially with the Python documentation. So it has a strong foundational model in generating the Python code, or code generation for debugging, for documentation and explanation, and for workflow automation. It returns the natural language processing for documentation and explanation. For workflow automation, it identifies patterns to generate the code. For debugging support, it identifies patterns of like wrong syntax that doesn't abide by the Python documentation. And for code generation, it leans on the Python documentation to generate some of the code based on your prompt engineering, which are keywords to generate the code. So now I'm going to talk about why LLMs pair well with Python. Well, you've got flexibility. You have open syntax, modular design to make it ideal for LLM-driven augmentation. It's easy to integrate with APIs, databases, and simulation platforms. And Python is also a relatively easy language to learn compared to Fortran, compared to Perl, compared to the older legacy languages that were used to develop reservoir simulations. Like if you don't know what I mean when I say Fortran or Perl, like consider yourself relatively a young person. So then you have context awareness. LLMs can see the structure of your code and suggest improvements or additions. You're able to adapt based on specific workflows, Delaware versus Eagleford, based on prompt context. So if I were to develop a type curve for all the wells production data in the Delaware Basin, it will lean onto its foundational model or its trained model on everything that's related to Delaware Basin and develop a type curve. But again, that is highly dependent on your prompt engineering. Got rapid prototyping. Engineers can iterate faster, test ideas, visualize results, refine logic in real time. So that is the benefit of LLMs with Python for sure. Because, for example, instead of trying to generate the code from scratch, which will take a significant amount of time, depending on what you're trying to build, the code is generated for you. And now the engineer is an evaluator and decision maker and is empowered to understand how wrong is the model, how wrong is the code, or how beneficial is the code, and what do I need to do to refine the code, whether if it is going back into the large language model to refine it, or copy paste into your Google Colab or Anaconda Jupyter Lab and start refining that code with the upskilling that you've already done in Python, assuming that you've already developed that Python capability. And then you got skill bridging. Non-coders can interact with Python workflows through natural language and expanding team capabilities. So for example, with an example that I can see that non-coders can interact with Python workflows is the commentary or the documentation that is paired with the code that is generated from the LLM. If you ask the LLM to generate code, but also generate commentary to explain the code, that is a lingua franca for non-coders with the LLM. That way the non-coders can understand like what is the functionality of what the Python code is generating. Then the non-coders can now be empowered and be an evaluator of the code to copy paste into Google Colabs or to provide the input for the engineer. So when I think of non-coders, I think of junior engineers and field techs, but I can also think of like managers who haven't touched a coding platform or touched a coding language because they're so busy making decisions and hearing presentations and being in meetings. So management, for example, can develop that eye for Python workflows through just understanding the natural language and the documentation and the commentary, and lean on to their sniff test and litmus test to see if the code is right or not. The code is doing what you would like for it to do. Now, from write every line, you can describe the problem. So that goes back to the prompt engineering. So again, build a type well from the CSV, clean SCADA tags, and plot top 5 alarms. I wouldn't suggest being this general when it comes to inputting the LLM, unless you have trained the model significantly for it to think like you and for it to train on the data. If you've given it data to understand what you mean by different SCADA tags and define the top 5 alarms. Because the way the large language model is going to read the clean SCADA tags and plot top 5 alarms is going to look at the header of the table of all the SCADA data and understand like what tag and like find what tag is or find what alarm causes using natural language processing. And then it will generate that column or generate some grouped statistics to generate the top 5 alarms. And then building a type well from the CSV, you would need to have the proper input of what the CSV holds of production data. You get my drift. You get the point where you really need to train the model for the model to work for you. So therefore, when you train the model and have the model to work for you, you got the time savings and the cognitive load reduction. So it reduces repetitive work. Time savings is you don't have to write every line from scratch. And then the cognitive load reduction is you don't have to think about generating the code because the code is already generated for you. And I'm repeating this time and like I'm a squeaky wheel, that you are empowered and you are the decision maker, and now you are the evaluator of what is being generated. So now I'm going to talk about practical applications in oil and gas. I've already generated the examples, like build a type well from the CSV. So now we're going to talk about forecasting, auto-fit decline curves, type well libraries. You can auto-fit decline curves using LLM-generated Python scripts for bulk well analysis. You can build type well libraries across benches, pads, and vintages. Again, you have to make it clear for the header, for the vintage, pad name, bench name. Like, I'm already picturing the Excel spreadsheet or the CSV or the SQL database that has all this data and where the large language model is going to gravitate towards to do the grouping. Then you have the probabilistic forecasting with uncertainty bands and outcome ranges. Early EUR indicators derived from hourly flowback data validated by simulation. And then you can have integration with Aries. Yeah, Mosaic, it's a Canadian version of Aries, or PDP forecasting and scenario planning. So that's like the gist of the forecasting. Again, not an exhaustive list of what you can do with respect to forecasting, but this should give you an idea of the strength and the capability and the time savings you can have by like not having analysis paralysis using Excel and grouping your wells, the human error that gets incorporated into repetitive work. And all you have, when I say all you have to do, that I think the skill you would need to refine in this regard is the data preparation, having the right data, and then being able to provide the right input in the large language model to get what you need. So now I'm going to talk about diagnostics, choke schedule modeling, flowback analysis. Choke schedule modeling, you can use nodal analysis and you can use drawdown optimization. So you can input the different kinds of choke sizes and then production data, and the large language model can generate whether if you're optimizing for the most amount of production based on historical data that's been trained. So flowback analysis is to detect sand flowback, water cut trends, crop and embedment effects. So it would need to look at a control value or a control case where there's no prop and embedment, and then one with prop and embedment, and provide that output. Lift drift detection via SCADA, signal parsing, and cycle tuning recommendations. So another example for this is like using SCADA signals and then seeing whether if like wells are cycling an artificial, like for ESPs, and whether if you need to refine your artificial lift strategy. There's alarm noise reduction with top 5 actionable. So I already mentioned that before. And then jet pump and erosional velocity diagnostics automated across asset portfolios. So again, you would need to input that there's a jet pump, there are the erosional velocity values, and evaluate whether if there's a high erosional velocity for that particular data set. So those are, again, not an exhaustive list, but these are just some examples you can think about for practical applications in oil and gas. And full disclosure, I'm a reservoir and a production engineer. So that isn't to say that you can't apply this into drilling or geology or facilities engineering. These are just the examples that I'm the most familiar with in determining how large language models can work for you. And for those of you that are reservoir production engineers, you may be able to resonate with some of these applications, and you may want to try them out yourself with the data that you have into the large language model. So then For those that work in databases and that are office engineers and that are also reservoir engineers, you can use data integration with SQL, Python, and LLM for Aries and Whitson and merge them together. You've got SQL and Python and LLM pipelines to merge SCADA, Aries, and then Whitson plus data sets, automate well prep for simulfrac sequencing and DSU, drill spacing unit, cube development, Snowflake integration for multi-operator data harmonization and real-time updates, PVT table reconciliation across vintages and uncertainty zones, and then equation of state and volumetric data merging into mappable reservoir grids. So imagine the capability of Python to develop, like for you to input spatial data, and then for the LLM to generate a map using some of the Python libraries or using some of the Python packages that are out there to generate those maps or to generate those visualizations. And the LLM can do that for you. I'm trying not to oversell LLMs. I'm trying to tell you that you can save a lot of time by not developing code from scratch. But at the same time, you're going to need to understand like what is right code from wrong code. And you're going to need to know how to make the code work for you, which still requires upskilling in Python. And I will be a broken record, and I can die on that hill for that. Then you have visualizations like dashboards, Unity plots, and EUR maps, lift performance, alarm actions, and methane compliance, Unity plots to highlight outliers and fit quality across decline models, EUR maps layered with spacing, completion, and geology metrics, and then interactive visuals for boardroom, regulatory, and field audiences. And then, yeah, you can even generate PowerPoints and PDFs from sprint deliverables and pilot results. Like, I think the best example I can figure out is like how I use AI today, or how I use AI in my contracting work for Python. Extracting data from PDFs, so generating code to extract data from PDFs is one way that I use. There is a PowerPoint generation, like PowerPoint presentation generation for like finalized products. But for Python purposes, it is generating the code for it to interact with other document types. And then, of course, generating code to get a better understanding of how data sets are grouped to generate insight. So think about data to insight to action. You have the data. What comes in the middle is the LLM and the Python code that gets generated for you to use. And then, depending on your prompt engineering, you can also ask the LLM to generate some insight so you can get the insight much faster. And with that insight, the hope is, even though hope is not a strategy, the hope is to generate some action out of it, like some action items or from some resolution. Now I'm going to talk about prompt engineering, and I've talked about it and I've led it up to this moment. And I want to provide some tips on upskilling in prompt engineering, not just something general. You need to be specific, and you need to understand what the intent is when it comes to generating your Python code. So you need to start with clear intent. Write a function to calculate water cut for oil and water volumes. So that's better than help with Python. Include domain context. Use API gravity to estimate oil density. That helps with model alignment and industry logic. You need to define input and output formats. Clarify the expected data types and structures. Like input is it's a pandas data frame with columns, depth, and pressure, and then request modular code. So split into helper functions for pressure gradient and fluid density. So these are, again, the assumption is you fed a certain data set to the LLM, and then you can generate these prompts. That could be specific enough. You don't want to rely on the foundational model, like without feeding it a data set and then you generating this, because Python is going to identify patterns from its foundational model, not the model it's been trained with. I mean, that you haven't trained it with. When you feed it with data, like the data set that you are with API gravity, oil density, water cut, oil cut, then it can identify those patterns and generate what you want. So use constraints to guide style, specify libraries, performance needs, or coding standards, like use NumPy only to avoid loops and speed. The beautiful thing about Pythons and LLMs is that there is just like open source and like open documentation that is out there for Python that the large language model is well versed into coding into Python. So make it work for you. Ask for comments and doc strings. Include inline comments and docstring explaining the function's purpose and parameters. Iterate with refinement prompts. Now optimize for memory usage. Add error handling for missing data. Using examples to anchor logic. Provide sample inputs and outputs. If the input is 100 barrels of oil and 50 barrels of water, the output should be 33% water cut. So teach it to identify patterns. If the data does not have, so the best example to give is, suppose you have data prepared for a well that has never experienced downtime. How can the LLM predict downtime and extrapolate that if it's never been trained to have seen downtime? So that is a question. I'll leave that to you. And then request visual outputs when relevant, like plot pressure versus depth using matplotlib with labeled axes and grid lines. Test with edge cases. Include test cases for zero flow, negative values, and missing columns. Chain prompts for workflows. First generate code to clean well log data, then code to calculate porosity. Use role-based framing or tone. Act as a reservoir engineer writing Python for a regulatory report. That's an example. So now I'm going to talk about some risks and guardrails. For those of you who are familiar with hallucination and error propagation, I will define this very in layman's terms. Model hallucination. That way you don't think about another definition for hallucination. But model hallucination is meaning that a great example I can give, and I heard this before, is determine my birthday based on the color of my shirt. The right way for the model to have the guardrails for that is the model to output saying like there is no such correlation for that. But what we've seen in LLMs is that they will try to generate a correlation between your birthday and the color of your shirt. Probably tap into some astrology and horoscope readings and then come out with some answer that is not reasonable. That is hallucination. Hallucination is the ability for the Python or for the LLM to generate an answer based on either based on like data that has never been seen before, or based on data that it hasn't been seen before, or based on a sparse data set, or based on an unrealistic correlation, or based on contradictory like correlations. The model's going to hallucinate. Then you have error propagation. So LLMs can generate confident but incorrect code, especially edge cases or niche workflows. There's errors in logic or syntax and may look plausible. That can lead to false assumptions if not caught early. If you're using bulk forecasting, hallucinated code can skew the entire asset evaluations. So for example, you're asking for the Python code to extrapolate a type curve that has never been seen before from the trained data. LLM is not going to stop. LLM will try to give you that answer, any answer. And then mistakes can cascade across workflows. Like flawed PBT inputs affecting simulation, EUR, and economics. That is why it is so important to still have the upskilling in Python coding, having the practice of writing from scratch in a Google Colab or Anaconda or Jupyter Labs, and then understand and have the reservoir engineering expertise, production engineering expertise, drilling expertise to be that evaluator, effective evaluator, to be that empowered decision maker, to validate the code. So then you got ethical use, transparency, and model training and data sourcing. Like LLMs are trained on public and proprietary data. You should understand the difference between the two. Avoid LLMs to process confidential or sensitive field data without proper safeguards. Be transparent when using AI-generated outputs and regulatory filings or investor presentations. And encourage open documentation of workflows, assumptions, and model provenance. And then the final slide I'm just going to leave everyone with is that for upskilling, you need to develop the Python upskilling, and then there's a new skill for prompt engineering. And prompt engineering will become better when you know the Python code better. So they both work hand in hand. When you have the Python literacy, you can be good at prompt engineering. When you're good at Python engineering, it will enhance your Python literacy. So you have workflow ownership, engineers or architects, again, the decision maker, the empowered evaluator. And then you have cross-functional collaboration. So this is like people who are non-coders that can understand what the code is talking about through the commentary. So now I'm thinking about what's next. As an AI activist, as I call myself, and Alan calls himself as well, what is next? You can get LLMs embedded into SCADA platforms, got real-time diagnostics with natural language queries, and then AI co-pilots for regulatory reporting and methane compliance. Those are hot topics. And then, you know, I have a webinar, like this is the webinar for Python and LLMs, but you can also take a course on mastering those LLMs too. So I have a course on AI mastery, like how to make Copilot work for you, how to make ChatGPT work for you with the various amount of reports that you can feed it. So feel free to reach out to me for extended knowledge on that or for more information on that to continue the conversation. With that being said, that is everything that I had to share today, and I'm open for questions.
Cool. Thank you, Yoshi, for that pretty good coverage of this terrain. Guys, I'm gonna just open up. Please raise your hand there if you want to ask a question. Simply type in the chats. Meanwhile, I have a couple of questions myself, Yoshi, if you don't mind. I'm just curious, those examples you listed, you said yourself it's not an exhaustive list, but you presented quite a few of those examples. I'm just curious whether you presented those in terms of the opportunity spectrum, things that could be done, or those are actual examples that you have developed yourself or you have seen developed by others. If so, are those, you know, bits of code shareable? I mean, users can find them somewhere and have a play with those examples themselves. What is it exactly that you shared there in that list?
That's a great question. One thing that I will say, that's what I have seen. So I don't have the code that is shareable, but I can definitely guide in like what kind of prompt engineering is needed to generate that code. But that is what I have seen done for auto forecasting, for decline curve analysis, the identification of top 5 alarms for SCADA. Yes, and then mapping based on spatial data that you input. So I've seen that done.
Okay, and I think we touched on this before the session, but you've seen that developed by individuals and kept at that user level, or you've seen that translated into, let's say, interactive apps deployed at scale inside companies, or it's still at that user base level?
It's a great question. It's actually at user base level at the moment because I think there's a lot of curiosity on artificial intelligence, but as we've talked about prior to the recording, there's a lot of inertia of just getting enterprise solutions deployed, and there's a lot of vetting, there's a lot of questions on how to make artificial intelligence work for you, or like how to unravel that black box.
Yeah, for sure, for sure. Anybody, guys? Anybody else? I'm gonna go with another one myself then. This is very interesting to me. Can you explain, Yoshi, what is it that you have done yourself or you've seen done in the way of training? And I don't mean training, at the developer level, these huge companies training their models based on these humongous data sets, but at the user level, again, what is it that the user can do to train these tools to their data?
That's a great question. So that goes back to the prompt engineering skill that you need to develop. So an example, basic example, have a CSV file of a bunch of data, feed the CSV file, ask using prompt engineering general statistics of the data. So therefore the LLM is trained with that data set and is trained to answer some of those questions with the data set. Then you can feed some information to the LLM saying, well, the header is going to be the first cell. Like, you don't have to say that, but you can be sure. Header is going to be the first row and things like that. But it will immediately assume that. But then you can ask the question of what is the best way, or like what are the top 5 alarms. So if there's a SCADA data set that you have and there are different tags, then the LLM is going to group some of those statistics or group some of those tags together, and then will output what is the frequency, what is the count of those tags, depending on like how the LLM is going to read it. You can tell that every cell is a frequency, every cell is a count. So therefore the LLM is going to group the tags and output what are the most hits on, like, what have been the most frequent tags of the SCADA data. So those are some examples of prompt engineering based on data that you feed. So a lot of it is a lot of domain expertise training, like how would I want to see the data, and then making natural language processing work for you for that the LLM is foundationally trained on. So it's like meeting
Yeah,
in the
yeah. Yeah, no, that's great to clarify because, training a models could sound a bit scary for many folks, but the mechanics you're describing is simply uploading stuff and then just talking and passing instructions in plain English. And this is how you train, or, this is the response that I'm expecting to see from this type of query. So it's good for folks to have that clarification. Okay. Thank you very much, everyone, for joining in. Thank you once again, Yoshi, for this very comprehensive description of this territory. And as I said at the beginning, this session is being recorded, so I'm just going to publish on our YouTube channel for later distribution. All right. Thank you again, everyone, and have a great day. Thanks, Yoshi.
Thank you for having me.